Thank you. Thank you very much, Jan, and the group for organizing this wonderful homage for Paul. As you heard last 2 days, we talked a lot about Paul as who brought the plate tectonics to the continent. And I would like to show you that Paul was just not interested in the continents. He did a lot of work on the continents, no doubt, but he started his work in the ocean. I'll be surprised to see that. So when Jan asked me to give a talk about the legacy of Paul in marine geoscience, it immediately came to my mind was active tectonics in marine. And that's what I was aspiring when I moved here after working with Paul for a month at sea. And I was trying to kind of get all the marine geoscientists from tectonic life to marine geoscience. It took about 20 years to get that. Finally, we succeeded. Then I realized while preparing this talk is that Paul did not do just active tectonics. He really was a tectonician. So I will kind of show you today, Paul was indeed a real tectonics person rather than just active tectonics. And I was fortunate and tough way to be spending a month with him at sea. So we'll see some of the results from there. With that, so here are some of the photographs from, Paul always, maybe for the light. This is, I think, Ellen was not mentioned, and she was kind of, I would say, right hand, left hand, up and down, everything for Paul over the 10 years of his life in Singapore. And obviously, you have seen most of the other people around. Here, you will see some of the, I'm sorry, where is Matthew? He got cut here. So this is Atta, who did PhD with Paul, and myself hanging around with it. I was so upset that I had to grow a beard during the cruise. So anyway, so I'll take you to the tour. So as I said, Paul started working in marine geoscience while he was at MIT during his 2 years of séjour so he was debating, working with Paul Tapponnier or with Peter Mollard or in marine geoscience. And that's where he met Jean-François. They were together. And Jean-François introduced to him that, hey, what's happening at sea means we are developing this plate tectonics. And the model which was developed at that time was based on the Bob Parker and Oldenburg theory, which suggests that the plate cools, the lithospheric thickness on the ridge axis is close to zero, magma comes to the surface. And the whole model was based on that cooling of that lithosphere, thinking there's a large low velocity in the mantle. Jean-François and Paul realized that at the slow spreading ridge, that is not the case. There is a axial valley where things subside. Immediately, it came to my mind, he likes the fault. One thing he always loved is faults. So he realized that faults is maybe the cause of all this problem. So they developed a theory, which they published in 1978. This was his second paper at that time with Jean-François, saying that necking of the lithosphere at the slow spreading ridge, and they introduced at that time the faults and did the modeling to suggest that as you move away, apart from forming the oceanic crust by magmatic process, which is the concept developed before that, a magma coming and forming crust, he realized that to have that axial valley, you need faults. And he put about 6 kilometer thick oceanic crust and realized that it will break. So the crust is not just formed by simply magmatic process, but is thinned by tectonic process. So that's what happened. And after 1978, this is the first time we can image that fall in 2025, just to give you the age it took to get to that level, the Paul's imagination and what we are getting today. So and when I was citing this paper several times, I didn't understand necking. Necking is simply, in his case, extension and faulting. So that was his first contribution. Then you have heard a lot about indentation theory, which Paul introduced, the formation of South China Sea. And that was not just based on the work with Gill and others. He went to sea in South China Sea to confirm his hypothesis. And obviously, Anne will develop that idea more. But I thought that just to introduce that, at that time, there were two cruises organized in 1985. Anne was saying that there was, Jean Charcot was traveling all around the world. She went to South China Sea, and she will talk about it. And there were two legs. One was the Nanhai, and one was the Manila-Singapore transit, and she will develop that. And Paul happened to be, for the first time, going on the Jean Charcot, and discover the story which Anne will develop. And since I met Paul, he wanted me to go to work in China Sea. I refused all the time because for my own reason. But I did work on Andaman Sea, which I will. And he was telling me that using his tendency, this theory, everything is found by collision. Not being a tectonics person, it took some time for me to understand. So I partnered with Jan Klinger later on, and we worked together on the formation and evolution of the Andaman Sea. We had a PhD together, Aurélie Jardin. What we found that, this is your Sagang Faults come from the north, which Paul has predicted. And in fact, Paul has also published a paper called West Andaman Fault before anyone else. So I was surprised that, and he has extended that all the way and formation of Andaman spreading center. What we found when we looked in detail, we do not have time to go into, is that Sagang Faults from here and Western Sumatra Faults coming here. In the beginning, they were somewhere here, and that was initial stage. And slowly, over the last 4 or 5 millions, things are moving from this side to that side. So it's very likely has to do with the rollback and combination of initial condition and today. So basically what is happening is that initial condition, and these are all fracture zones of fault, not south fault, moving towards the west as the plate is subducting, rolling back westward. I talked to one scientist today. He said that he took Paul to Gulf of Aden, and some of the work was done by Paul again in Gulf of Aden with the Masako Tuyo and the team. The first person who worked on was Isabel Meneghetti. She did PhD mainly based on the work on land and the existing data set. But there was an experiment done in Djibouti area here, which on the vessel Atlant in 1995. And Paul did not go, obviously. Paul was always avoiding at the last minute, say, I'm not going. So Philippe Husseau was the chef de mission, Isabel Meneghetti. They acquired some of the data set, bathymetry 3.5 kilohertz. And Laurent Audin was the PhD student. So I'll show you some of the results. So here is the bathymetry data of the Gobi Rift Zone, which is the further west side of the Gulf of Aden and extend toward the Assal Lake here. And here is the bathymetry data acquired at that time. And this is the famous volcano which erupted in 1978 or something like that. And this is the Mid-Atlantic Ridge at Lucky Strike. And if you see the similarity between this and that is incredible. I rotated the Lucky Strike image from our work. And so Paul saw the link between the slow spreading ridge and the rift system. And here is a central volcano, and how the volcanic construction takes place and the normal faulting. And obviously, echelon faulting we see here in both cases. Here it is propagation of the rift. After that, it joins the northeast system, but here Lucky Strike continues that way. And they also did 3.5 kilohertz seismic image, which was very interesting for me to see that. And you could see the normal faults. And here is the study I did with Jan Klinger in the Andaman Sea, which is a sedimented spreading center. So you could see the similarity between the two. You could map the faults. And here you could get the age of the sediment, the rifting using the records. One thing I noticed while reading this paper, that there was no basalt flow in the sediments. Mainly the eruption occurs at the volcanic center, whereas here we see a lot of subsediments, lava flow injection. So, so Paul could see that a long time ago. And after that, he continued, he worked with Nathalie Fayet and Christine Daplus and Isabel Manighetti, and developed this Agua de Mar cruise, which took place in 1998-99 on Atalanta as well. He was supposed to be chief scientist, and on the board somehow he skipped and gave it to Christine, who led the cruise finally. And they acquired bathymetric gravity and magnetic data set. The main discovery, which Nathalie will talk about, I'm pretty sure, is that instead of, we think that when we have a subduction, everything is parallel to the subduction. Here they discover normal for perpendicular on the volcanic arc. And that was a kind of very exciting story. And I'm sure Nathalie will develop that in her talk. Finally, I got involved in, that was in 2002-03. I was in office with Claude Jopard, and he said, look, you should have chat with Paul. And Paul needs some help to have a cruise. And I met Paul, and he said, the cruise name is Solimar. Oh, wow, you could see, people know Solimar, right? Who has been to Kashmir, one of the beautiful palace in Kashmir. We saw Roger showing some of the images from the this is one of the beautiful garden in Kashmir Valley, built by Akbar, one of the emperor. So every Indian knows Shalimar, not only the perfume, by the way. Anyway, so I got excited about the name of the cruise, and I said, well, I'll join, because he needed to shape the museum. Because Ifremer was not very keen on giving any more vessel to Paul for the reasons we saw earlier. So I was kind of pushed on it. We did the cruise in 2003. Of course, I was the only person outside. The whole of the Tectonics lab was there. Jan, Jack, Jeff, Anne was there, right? It was fun cruise, but tough. Very, very tough one. The most tough experiment I had. Paul will come and say, I want this, I want that. I said, Paul, you can't have everything. You have to kind of, I'm the chef de mission, because the communication at SIP is the chef de mission commands, not the chef de projet. And he will go to the captain and want to do something. And the captain said, no, go to Dr. Sates. And he could see that. And in between that, there was his friend, Surzok, Lebanese, one of the Raal family. He was other person who would pull in. So we had a Singh, Tapponnier, and Surzok, struggling and trying to get the experiment done. It was a fun experiment, I would say. I will do another experiment with Paul again. I'm not sure about it. Anyway, we made one thing we did, all the work, we had a SAR, which is the deep toe bathymetry or seismic survey. And Atta did a very nice piece of work published in Geology, the trace of the 1951 AD earthquakes. And he will sit there and follow all along this fault. And so that was fun. By the way, just to the background where we are, here is the Dead Sea Fault, comes in here from this side, and there is a constraining bend, and that bend leads to the compression offshore Lebanon. And the 50-51 earthquake took place somewhere here, and that's the image of that. So that was based on SAR image, and the experiment was fun from the political point of view, because at that time, so there was an EEZ defined by UN. Israel thinks that EEZ of UN is not right, so they kind of, the first time we went up to here, we thought that we can do the survey up to there, but we were forced by Israeli to go back. And we end up along that was, so we will see some helicopters hanging around our, so it was challenging to say the least. Anyway, the fun experiment, we did a very nice bathymetry and seismic survey. And this is the fault, as you can see the fault, this one, which is a, what's the name, Carmel fault, a beautiful normal fault. And this is the first time I'm really seeing active tectonics from as a part of system. And obviously, survey allowed us to look at the deformation offshore Lebanon, and these are the top of the sediments. These are the deformed sediments. Underneath, you see Messinian salt as well. So there was a link between Messinian tectonics as well as the real tectonics. And Paul was, as usual, interpreting everything as a tectonics. So we had to watch out. One thing I discovered, I'm a theoretical seismologist, so all this was discovery for me. So I was having a really fun. Is that normal fault above the thrust fault, which was very interesting. So anyway, so we were able to see that the thrust continues for about 30 kilometers offshore Lebanon, and that led us to suggest that restraining band at that time, this is the restraining band coming here, and if you are at the continent-ocean boundary and you have a restraining band and create a thrust, you could start creating subduction there. So that was the idea we proposed in one of the paper with Helen we wrote early. So that was exciting period. Obviously, soon after that, in 2004, tsunami, Sumatra earthquake came, and we decided to I realized that I had to work with Paul because he knew the tectonics on land, and I needed someone to help me now with marine. And we joined the forces together and wrote several proposals. And in fact, I was very fortunate at that time. I wrote a proposal to Schlumberger at that time. That was around beginning of January. And within a week, I got an answer from Schlumberger. They will fund the experiment, and we did that experiment. But at the same time, we did propose reflection, high resolution seismic, and raw experiment. Only one got funded, which is refraction survey, which we did later on. Anyway, just to go back, there was not only one earthquake here. That was 2004, 2005, 8.6, 8.6 or 7, I think. And then there were two more earthquakes in this area in 2012. That is Strike-Slip earthquake. So I'll talk about those two too. So we developed a relationship with Paul working on those two projects. So in 2006, we did the survey with Schlumberger, who funded most of it. We saw 3 seismic lines, one here crossing the epicenter of the 2004 earthquake, one line connecting them, and one line connecting from this area all the way to the back arc. Schlumberger was very kind to provide a big source, 10,000 cubic source, 12 kilometer streamer. And obviously, as I said, we did the refraction survey. I was on the boat. It happened that 2 surveys took place at the same time, so I can't be on the 2 boat. So I had to divide the team into 2 groups, reflection, but at the same time. And this was amazing for us to see this. I had seen the economic sources, which are very small. Here we had big sources, long streamer, very exciting. Obviously, we imaged this is the profile, which is next to the Sumatra subduction, to the 2004 earthquake rupture zone. Normally, people up to that point had been imaging this part of the structure using conventional seismic, whereas here it allows us to image the downgoing plate, just not the top of the downgoing plate, but the moho all the way to about 30 to 40 kilometer depth. We also saw the back thrust, which is the backstop coming from the continental side, and the moho of the Sumatra crust. What Paul, and I give him the credit, he noticed, and I could not see faults. He will see faults everywhere. So he saw the breaking of the décollement coming and cutting through the oceanic crust, and there were supposed to be 5, 6 places where the downgoing plate was broken. And at that time, I think I went to ski in La Clusa, not very far from Nancy. I fell and broke my cheville. And I realized that once you have broken this one, you can't use the force. You have to have something underneath. With that discussion, Paul, that led to the idea that maybe the main mega thrust, which is supposed to be on the top of the oceanic crust, if you try to break the downgoing plate into pieces, you have to put the mega thrust below it. So Paul came with this idea that very likely that big mega thrust, earthquake of magnitude 9.192, they basically rupture in the mantle, not in the crust. That has been a very controversial idea. 5 minutes only. Anyway, so that has been exciting. And after that, Paul wanted me to come to Singapore. And I did not, my wife said, no, I don't want to go and live in the hot place all the time. So we made an arrangement for going for 3 months a year. And we wrote several proposals and did few surveys, which I'll show you now, 3 of them, in fact. The first one was looking at the Mentawai Gap, because KRC was obsessed that there should be a big earthquake here in the Mentawai area. There was 2000, I can't see. These are the 2 big earthquakes, right? And there was 2010 tsunami earthquake. I'll talk about that. So basically, this area is locked and we wanted to understand. So basically, what happens is that we had the vessel sitting in Singapore. That was the Volker vessel from the Smith Oceanographic Institution. And here is the team. Chenji was part of the team at that time, I remember. Yeah. And so we did not get the permit. So we had to go somewhere else outside. And we did a small survey for a week in this area. And I'll show you some of the results. There was a big earthquake of 8.6 here, and there were many papers describing the fault rupture of this guy. Only thing we knew were the reactivated fracture zone from the work of Christine de Plus. And this is our study area, and this is 8.3 earthquake, and that's 8.6. We did the small bathymetry, and we had Frédéric Leclerc from doing postdoc, and we kind of identified the main reactivated fracture zones and the shear zones. We suggested that at that time that these are the main rupture zone. They are kind of echelon form, and similarly, you have a shear zone. And obviously, we could see them not only in the sediments, deeper down. These are the reactivated fracture zone, and these were northwest south shear zone. So we suggested that the 8.6 rupture, the big fracture zone, this one in echelon form, whereas the part of rupture occurred along these shear zones. Finally, we got the permit. We went back to Mentawai region. We did the survey in this area. That was about 3 weeks' work. And Paul was interested in looking at what happens for the link between the earthquake, which is the 2010 tsunami earthquake, and the rupture zone. I had a paper in GRL earlier using CGG data set. I did not go into detail. One thing he noticed is that there are a lot of pop-up structures. So as you go towards the subduction front, you have several pop-up structures, in this case, about 9 of them. And he realized that may be the cause of the tsunami. Anyways, this is the work of Emma Hill and other people at EOS. And Paul was using the bathymetry and imaging, could identify the rupture for the 2010 earthquake rupture. I will advance rapidly. So basically, this is his idea that once you have a pop-up structure, instead of rupturing only this part, you uplift that one. Oh, wow. Okay, so basically the idea is that most of the tsunami is linked to that upward rupture. And here is the model he produced and that sketch. And finally, obviously, we went back for the survey in the 2012 earthquake rupture zone, 2016 and 17. And we mapped the whole area, and these are again, we discover these shear zones. And one of the key questions I work with orally and Paul that this F6 rupture zone we see here is about 400 kilometers long, and Paul was convinced that to have such a large earthquake, we need to have a nascent plate boundary. So orally mapped this fault beautifully and computed the slip rate, and we found that the slip rate along the fault is about 0.8 to 2.5 million per year, and the paper was published in JRL. And that theory still need to be tested. We did the seismic survey, and one main outcome of the survey is that along this fracture zone, we have extensive subsidence. So along with the strike slip fault, you have thickening of the sediments. And finally, this is the last slide for the science. There is a poster I suggest you to go and see, and here is the possible 8-point part of the rupture around 8.6. You can see the pull-apart system, beautiful, and Saksham will show you. Another thing you will see that this fault is not simply one simple strike slip fault, but there is a whole crustal level flower structure, and I would recommend you to go and see them. Finally, Paul's legacy continues, and we have not stopped. And Paul just did not do the continental tectonics. He was involved in rich processes, transform boundaries, and subduction zone. And one thing I liked about Paul, he has eyes which no one could see anything. He will see things. And one thing, I was upset that he goes to China, and what happened, I would have liked to come back, but I get inspiration from him that he continued to work to the last minute. And one thing about Paul, he was not just a scientist. He would have liked to be a king of France, obviously. And in Navarre, in one of the princely, with his princess, Kevin. With that, thank you for listening.